Now the problem with finding the inverse of a matrix is that you can't actually always find it. So if our equation is a to the negative 1, so the inverse of matrix A is equal to 1 over the determinant of A times D, negative B, negative C, and A. So that's our equation. The problem is that if the determinant of a matrix is 0, you end up with a 1 over 0, which is undefined. So you can't actually find the inverse of a matrix if the determinant is 0. So that is something we definitely need to check. So let's talk about what if matrix A is 5, 15, 6, and 18. So when we find the determinant of matrix A, we get, let's write out the formula first. So the determinant of A is equal to AD minus BC, which is equal to 5 times 18 minus 15 times 6. See, 5 times 18 is 90, but so is 15 times 6. So we end up with a determinant of 0. And since when you put that determinant into this formula, you get 1 over 0, that's undefined, so we cannot find the determinant of this matrix. So we'd have to write no inverse. And that would be the end of the question. So before you put everything into this whole equation, you should test the determinant first to see if and make sure that it's not 0. And if it is 0, you just write no inverse. So let's do an example of another matrix that actually, well, we'll see if it works. So we get negative 6 and 1 and 0 and 6. So we're going to just test the determinant. So if the determinant is not equal to 0, we are going to be able to find the matrix. So the determinant is AD minus BC, which is negative 6 times 6 minus 1 times 0. So then we just get negative 36, which is good because we can. So we are going to find the inverse. We are going to be able to find the inverse of this matrix. And I could keep going, but you know how to do this because I already did an example very similar to this.